Welcome back everyone. In today's video, we will discuss about generators in Python, which is one of the advanced topic in Python. As a Python developer, you may face interviews and most of the interviewer will ask questions about generators. Did you ever think why generators are so important? So let's look into the details. So what is generator? In definition, Python generators are a special type of iteratable that allow you to generate values one at a time as needed using the yield statement. Unlike list or tuples, which is compute and store all elements in memory at once, generators produce items on the fly, making them much more memory efficient, especially when dealing with large datasets. So basically, Python generators generate the data whenever you need rather than keeping in memory. Let's take an example. This is an example script to find squares of numbers using list. In this function, find squares uses a list to append the squares of numbers within a given range. As you can see in the script, for each number, it appends the result to the list. In the main function, we set max value to 10 so that it generates a list of squares of numbers from 0 to 9. Here, it stores these values in memory. If you create squares of numbers from 0 to 9, it will take very less memory, but if you generate squares of the numbers up to 1000 or more than that, or maybe like 10,000, it will definitely consume a lot of memory. So if you have large datasets to compute, it will consume memory, which is not a good practice. So in this situation, we can use Python's generator. We can use generator when you need to generate values on the fly, especially when working with large datasets, or when you want to save memory by not storing all values at once. Here, the same example with generator. In this script, we use the keyword yield, which posts the function, then return the value and allow the function to be resumed later from where it left off. For example, if you are generating squares from 1 to 9, first it will yield the square value of 1 and post the function and wait for the next call. In the next call, again it yield the square value of 2 and post the function. Similarly, it calculate all the numbers without saving in memory. So, generator provide each value at a time without holding on to the previous provided value. This is similar to when you request a page from an online book. The server sends only the current page without storing the previous ones. Similarly, yield produces a value which is squared value and post the function execution in each call. So in main function, we set the maximum value to 10. Then we assign the generator to a variable which is squares generator. But at this point, no computation has been done. The generator produces the values only when it's iterated over. In the for loop, we iterates over the generator object, square generator, and print the values. Also, we can use next function to get the next value without using the iteration. In this script, we are using the next function to retrieve the values manually. The next function is used to manually advance the generator and retrieve the next value. Each call to next returns the next square value in the sequence. When the generator runs out of values, calling next function, it raises a stop iteration exception, which indicates there are no more items to generate. Usually, when you are working with code, you are not going to use this next function, but you need to understand what the next function do. Also, when you create a generator, you need to understand how to use the yield operator. Here, the difference between list and generator. List stores all the elements at once. Generator yield one element at a time. So, minimal memory usage. List compute all elements upfront, but generator computes elements lazily as needed. List can be iterated over multiple times. Generator can be iterated over only once. List supports direct access to any elements by index. Generator does not support direct access, only sequential access. List is faster for small datasets due to upfront access. Generator is more efficient for large datasets or stream. What are the use cases of generators? First one, large or infinite data streams. When dealing with large datasets or streams of data where it is impractical to store all the elements in memory, in that time we can use generator. Example, processing lines from a large log file one by one without loading the entire file into memory. Second one, on-demand computation. When you want to generate values on the fly, particularly when generating values is computationally expensive or unnecessary until needed, in that case you can use generator. Example, generating the Fibonacci sequence up to a certain point where you only calculate as many values as you need. Pipelines and lazy evaluation. When chaining operation in a pipeline where each operation only processes data as it's needed. Example, reading a large file, filtering out certain lines, transforming the remaining data, then writing the results. All of these without storing intermediate results in memory. Then you can use generator. Single iteration over data. When you only need to iterate over data once, then you can use generator. Example, sending data from one network service to another in chunks where you don't need to retain the data after it's sent. So in summary, you can use list when you need to store and repeatedly access a collection of data in memory and the data size is manageable. Use a generator when dealing with large datasets, infinite sequence, or when you want to compute data lazily, yielding elements one at a time without storing them all at once. So that's all about today's video. I hope you got some helpful information about Python's generator. So please consider to support the channel. Thank you for watching and see you in the next video.